side mirror is a single-screen work that displays two identical twin cells. In actuality, the twins are two separate objects defined by a unique set of changing spatial coordinates. A careful adjustment of the properties of attraction and repulsion holds the rotating pair in a suspended state of hyperstasis. In this rapidly vibrating field, the two forms actually occupy each other's space, becoming in essence identical organisms. This dynamic is exaggerated by the sound generated by each of the twin cells, creating a feedback mechanism that perturbs and regenerates both visual forms at once. The 100-Monkey Garden is an artificial light installation that generates a new version of itself during each day of the exhibition. The installation utilizes a networked computer system to display real-time, live 3D animation to create an evolving population of abstract visual forms which make their own live sounds. On the left-hand screen, we see two hyperactive white shapes. These shapes are the parent forms. The parent forms are attracted to each other, and when they come together, they couple to create a child form. The child forms can spin wildly into a final nesting place or grow slowly over time. The surface patterns on the child forms are created by algorithmic processing of digital video noise. These surface skins also create their own collective sounds. On the right-hand screen is a complex undulating form. This form is also based on an audio-video feedback system which utilizes two separate data sets, each comprised of over 50 equations describing various theoretical geometries. When conditions are right, this shape-shifting form will grow very loud and transform into a shimmering red group or flock of objects. When this happens, the shapeshifter becomes a predator, who will eventually leave the smaller screen and enter the larger screen to prey on the child forms. If the right-hand screen is blank, the viewer should look for the predator among the parents and children on the left-hand screen. Often the predator is hidden from audience view, lurking just beyond the perimeter of the screen. This underscores one of the unique aspects of cinema as live simulation, in that there can be many invisible actors or elements occupying the data space beyond our view. These off-screen actors might exert very dramatic influences upon the visible elements within the synthetic ecosystem. In this case, the predator has a variable eating range. He may poison the child forms by being in close proximity, or be forced to pass directly over a child form to consume them. The children take on a brighter glow and then disappear as they are eaten. The dynamic interplay between the predator and prey will determine if the ecosystem remains within the limits of growth. This limit is defined by the processing and rendering power of the network computer system. In addition to these basic behaviors, there is also a latent gene that might emerge if the child population should grow beyond 100. If this gene is turned on, each successive birth will cause a number of the individual replicant children to change as a single group to adopt a new identical form and behavior, becoming like an army with a collective identity. The working methods involved in the creation of a cinematic simulation involve a mix of science, art, and technology. Much like a more conventional film, the artist-director acts as a dramaturge, coaxing increasingly complex levels of interaction from the Bio-Mimetic script. The programmers facilitate this vision with their own aesthetic contributions.
I do this whole craziness to basically look through all the genes and draw those four sets of letters that make up the gene sequence, and then I stick it in there.
Here, programmer Luc Dubois describes the methods used for the development of a genetic code matrix.
And there you can sort of see what it did. You know, it sort of draws the gene sequence on top of the square and connects lines to the parents.
The genetic code matrix will allow the system to evolve distinctive forms that carry both dominant and recessive genes, guiding the evolution and mutation of successive generations.
To see whether it collides. So check collision.
As the 100 monkey garden evolves over days and weeks, it may stay relatively unchanged, or display unique aesthetic characteristics that have never been seen before.
The particle you're checking with, so V is a particle I'm working with, and I want to make sure that I is not V, because they'll always be touching.
The ideas underlying the hothouse project are drawn from cybernetics, theoretical physics, and ecology. The project has resulted in a concept-driven approach that expands the traditions of abstract or absolute cinema, visual music, and sound art. By employing a genetic engine capable of generating an evolutionary synthetic cinema and recasting both the artist and the viewer as co-determinants within a dynamic system, we can create a new body of emergent aesthetic objects and experiences.
So basically what Corey and I are exploring is one aspect of artificial life, and it does have a relationship to another field, artificial intelligence. As many of you know that are associated with the complex, the birthplace of A Life really was right here in Santa Fe with the work of Chris Langton. And if we want to describe A Life, I'll just read the quote. Artificial life starts at the bottom, viewing an organism as a large population of simple machines and works upwards synthetically from there, constructing large aggregates of simple rule-governed objects that interact with one another non-linearly in the support of lifelike global dynamics. Probably the metaphor that's most central to our area of interest is complex interdependent